back to what Stephanie was saying, okay? But before we jump into the new stuff, let's make sure we understand the calculations that are necessary for number 7 on part 1. You need to show work. What do I mean by that? When we talk about the mean, okay, of a set of values, we know that we're going to be adding them. So there's going to be 12 numbers that we're going to add. Or I can just say this: the sum of the first 12 numbers divided by 12 is equal to the mean. Would you agree with that? The sum divided by the total number of numbers. And what was that mean? Does it give it to you? 37. Okay. So would you agree that that's, are we okay so far? Okay. So could I solve for what the sum was? Like if I were to just replace that with an x, would we be okay? And we could just multiply both sides by 12. And we could figure out what the sum was. Would you agree? Okay. So I'll just say the sum of the first 12 equals, and then you tell me what that number is. Now, how does the average change now when I have a new person that comes in? I'm no longer dividing by 12, but I'm now dividing by 13. So you need to show me that calculation, which means this, which means that this is going to change to a 13, and I'm going to add whatever the value of that sum was. Let me write it a different way, so I don't confuse you. Come on. So once we have whatever the sum is, the sum of the first 12 plus whatever her age was who came in late, I'm going to divide now by 13. You should be able to answer that question, because you have the sum, you have the age of the person that just came in. Are we okay with what I just said? You sure? The key to what Stephanie was asking is that when you find the mean, when there's only 12 people, you divide by 12. When one person entered the door, there's no longer 12 people in the room. There's now 13. So we had to find that. You have to find the sum first. Find the sum. Put that number here. And then put the age of the person that came in late. Okay? And that will give you the answer that you're looking for.
What if you did it another way?
If you can show and your work is clear and I can understand what you did without any further explanation, sure. I don't know another way to do it. So I'm not sure there is another way. The mathematical language. All right. So this was your help on number 7. Were there any other concerns? Thank you, Stephanie. Any other concerns or questions on 1 through 8 besides the spread stuff, which we'll get to today? Anything else? Yes, sir. I'm going to count number 6. I'm not going to collect it right this minute, baby. You're going to get like 10 minutes at the end of class to finish. I'm trying to remember names. Hang on. Eva Rachel. Shh. Quiet. Yes.
For number 6, when it says no more than 3 numbers are the same, does that mean there can be like one number has... Like,
3 numbers can be the same, but no more than 3. So you can have like 10, 10, 10, but then no more 10s can be in the group.
What if they're like okay?
You could have 10, 10.
I think
Yeah, 10, 10.
Oh, multiple sets of 3 in a, yes, that's okay. Let me read the wording to double check that.
It says no more than 3 numbers are the same.
That's okay. You can have multiple sets of 3 that are the same. Right. Anything else? Clarification. Okay. I would like for you to put that away from me until the end of class. Okay, I don't want to see it out right now. I will promise I will give you some time to look at those 8 questions. But go ahead and take your notes out, because we are going to move on to another part of univariate data. So far, we've talked about shape. We used a lot of vocabulary last class. We talked about skewed right, skewed left, uniform, mound shape, symmetric. We know what it means to have, or for a data set to have shape. We talked about center. Center, we used really 2 words to describe center. Rachel, you got a question?
Is there like a rule about setting up things?
And here? Come on, girl. There's 2 words that we use to describe center, or 2 measures of center, and we compared them even last class because they are tied to shape. And those measures of center are mean and median. Okay? Today we're going to focus on several different measures of spread, because as I mentioned last class, shape, center, spread, all 3 need to be addressed when you are describing a distribution. So we've already done those. Now we're going to focus on spread. I happen to think range is the weakest, don't even write it down. It's the weakest measure of spread that there is. Why do you think that's true? Why is the range probably the least popular, or the least one? I don't really ever want you to use it almost. Okay, that is the definition of the range, max versus min, but why is it not really giving me a good estimate or a good description of what's happening in the data set? Did you have your hand up, Sammy? It doesn't tell you much at all. What does it tell you, Hunter? Perfect. Okay, that's really the key. Outliers mess it up. Okay, if we look at our population of NFL salaries so far, I forget who this guy was. Who was it? Do you remember his name? No,
I know there was one for 11 mil. I think that might be.
I don't know who he is. Okay, Peyton Manning. I know he's in there. He played in the NFL in 2009. But anyway, this guy's messing it up, right? It's not really giving us a true description. If I take the maximum and I subtract the minimum, I really am not. It doesn't tell me really much of anything. Okay. So the range is a descriptor of spread, but as Hunter said, outliers mess it up. Okay? They kind of exaggerate the truth, so to speak, of what the range would be. Okay? But it is, in fact, just the highest and lowest. It is the worst way to calculate spread. Now, I think in part 2 of your univariate data packet that I've given you, you are calculating the range, okay, which is not a big to-do. It's probably the only time you'll ever do it. That's all right. But it is a measure of spread, okay? Let's look at some that are more beneficial to helping us describe, okay? And the first one we'll talk about is called the 5-number summary. Okay, and you guys have already probably used the 5-number summary back in pre-algebra and algebra. It is what is used to make box and whisker plots. We call them box plots in AP Stats. Matter of fact, sometimes we, we'll just call them box plots. Notice what the first bullet point says. Okay? Whenever we're using the median to describe the measure of center, we're going to use the 5-number summary to describe the spread. So my question to you, do you remember, when do you use the median? What shape must it be? Devin? Nope, actually it's the other one. Kemerson? Could be, but if the data is really heavily skewed, the median is actually the best measure of center that you want. Okay? Right. Okay? So, right. The average, if you remember when we talked about comparing the mean and the median, when we have a heavily skewed data set like our population over here, isn't the mean being dragged by this guy over here on the calculators? The mean is being dragged further right. So he's being manipulated, right? We don't want that. We called that the resistant versus the non-resistant measures of center last class. The mean is being pulled. The median is only going to move over one little bit, right? It's not going to be as pulled further away. So when you have skewed distributions, the median gives us a decent picture of the center, and that's what you need to use. So you always want to figure out your shape first, okay? Then you're going to figure out your measure of center, and then you're going to worry about the measure of spread. So when we have a skewed left or right, it doesn't matter. Or if we don't know the shape, sometimes the shape is an unknown entity, median is probably the best. In our area, okay, it's probably a little bit, it's probably for us old people, but I'll tell you anyway. We talk about median house prices, okay? So we talk, like for example, the new high school that's being built, okay? All this roo-roo about the new high school, right? Oh, well, you know, what's his name? The superintendent's kids are going to go there, so they get a pool, you know, whatever. But when they talk about descriptors of that area, they talk about the median house price versus the median house price in a different area. Why would that be a good measure to use as opposed to the mean house price? What would if I, let's say that, you know, Mrs. Mackert, I hit the Mega Millions, and I'm going to go and buy me a nice house, okay? And I'm going to live in Prince William County in the middle of Manassas. I'm going to build me a mansion, okay? In the middle of, I'm right next to the mall, okay? I'm going to be right there. Wouldn't I kind of affect the other house prices around the area, okay? So wouldn't a median house price be a better descriptor of the typical house price in the area? Okay, so that would be what we would use there. Okay, now let's go back to the 5-number summary thing. Okay, what are the 5 numbers in the 5-number summary? Hopefully you know this by now. Minimum, Q1, Q2, Q3, and the max. Okay, now Q2, I never call it that, ever, ever, ever. It's always the median. Okay, so it's just, we skip 2 to get to 3. Notice what I've written in blue. You learned this before as well. That the first quartile has the lowest 25% of the data. Quartile 2, okay, because it's in the middle, if I want to kind of to draw it on a little graph here, let's pretend we're going to draw a box and whisker plot. Okay, pretend. This little whisker down here would have 25% of the data. This would also have 25, but from here to the median, wouldn't it have 50%? Okay, that's what we're saying when I say 50% below it. Okay, and then we have Q3 over here to the right, the last end of the box, so to speak. And that would be another 25%, which means 75% below it, and so forth. Okay, each of the quartiles is 25%, quarter 25. Okay, we know this. This is something we've done. Question? Yes, just go ahead. I figure we're all, if they yell at you, I'm sorry, Hunter. They'll come back and drag me out by my toes, I guess. Okay. Stuff we know. So it's going to be on Fusion. You know that by now. Okay. So let's look at the example we looked at last class. Okay, those test scores from Algebra 2. Okay. If you remember, these were the original before I made somebody come in and take the test. Remember the outlier came in? We looked at the outlier test. Remember that last class? Okay. Remember the median? Let's double check, because I think that there's some mistakes on this, and I want to make sure. Can you just find the median of that data set for me double quick? Just double check that it really is 79. I'll pause the recording while we do it. Just plug it in real quick and just double check. Now, this little group over here was saying, I can look at it, Ms. Mackert, I don't need my calculator. And of course you can look at it to figure it out, because we know the median is a position. Okay? We're going to find the middle. That's the middle. So the lower half is 5 values, the upper half is 5 values. The middle is a position, which means it's the average of 78 and 80. That's why 79 was the median. So really, you could just look at it and tell, and you're exactly right. But I just wanted to make sure that we remembered how to use a calculator portion. Okay? So we know that. Okay? The quartiles, if we were going to do them by hand, okay, once we have where the median is, the lower quartile is simply going to be the middle of the lower half. Okay, and then over here we have the middle of the upper half. So we have Q1, we have the median, we have Q3, we have the max, and we have the min. So we have our 5-number summary. And hopefully it matches up with what the calculator gave us. Okay, and it looks like it does. Yay. Nice when they work together like that. Okay. Now, when you create, I alluded to this last class, when you create a a box plot, what is essential for you to have? Scale. Okay? Got to have a scale. So, the calculator creates one for you. Okay, have I shown you how to do that yet? I think so. Want me to remind you if you're interested? Okay. If you have the data values stored in your calculator, which at least I do here, we have to make sure there's nothing in my y equals, and there is. So I'm going to clear it out. Okay, I don't want anything in there. If your y equals looks different than mine, it's just because I have an inequality program running. Don't worry about it. It's an app. I'm going to go ahead and go to stat plot, which is second y equals. Okay? I'm going to turn it on, which means I'm going to hit enter. Make sure it's on. You'll need to use your arrow keys to go between on, the type, X-list, frequency, mark, etc. Your type is going to be the first box and whisker plot you see with the dots after it. Okay? The second one doesn't show outliers at all. And then you'll have to go to zoom and then stat, which I believe, depending on the version of the calculator, is zoom 9. But let's double check. Yes. Got a pee-pee before you get here. Zoom 9. Okay? So here we go. And if you remember, if you hit the trace key and arrow over, it will also show the quartiles. Just to review. Okay? So again, trace, which is up at the top, and then arrow over. Finding where all these buttons are on the calculator, I think, is half the battle. Okay? Zoom, trace, all at the top. And again, you'll have to create a scale. Notice the calculator doesn't do that for you. Okay? You need to do that. So in order to actually graph this, we need to start at, if we're going to create a scale, let's say, I think 65 all the way to 100. Would that work? Would that be encompassing? Okay. So then we could just go by 5, 70, 75, 80, 85, 90, 95. Okay. And then we would just create our scale. What's the problem?
To 60, because there's 64.
Is 64 in there? Look what I'm going to do. 64. It's not an outlier. It's going to be the end of my whisker. I just created a scale and just make sure it's a little bit to the left. It's okay. But you're right. I probably should have gone to 60. All right, and then we go to 70. Then we're going to go to 79. Then we're going to go to 87. And then we're going to go to 99. Now, in addition to the scale, and this is something I would like for you to do, if you don't have the quartiles listed off to the side, if you do, that's fine. But it's beneficial and easier for me to grade if you simply just, what was this one? 70, right? And then
79. And that's
89.
87.
No,
Not
I'm making
confusing the teacher.
So 87, 79, 99. If you would please just write the quartiles there just to make it so I could grade it quickly, I'd appreciate it. Okay? Just have them listed. Or you can have them to the side, but honestly, as long as they're in order, that'll be okay. Scale, listed, quartiles. I will be looking for both of those. Now, on your, I talked about this last class, but I want to remind you, on the creamy versus crunchy peanut butter one, you have to have one scale, both box plots. It is okay if you put one below it and one above it. I'm fine with that. Okay, or you can just put them right on, whichever one. What will be important is that you tell me which one's crunchy and which one's creamy. Because if you don't put those words, I don't know. I can't assume. You know what that does. Perfect.
I like color.
As long as it's clear, and as long as I understand, I'm okay. So if you can write it on the inside, crunchy, creamy. One scale for both. It cannot have two different scales. Yes? Now, the reason that you have to have one scale, and you're going to be doing more of this next class, because we're going to actually, on Thursday, we're going to make helicopters, and we're going to time them, and we're going to collect our own data, and you'll do the same kind of thing with that. When you are comparing, you need to actually have the box plots right next to each other. So I'm just going to kind of make a false one up, okay? So just watch what I mean. Okay, I'm just making one up. But this green graph, or this green box plot, has the same scale as the other one. So let's kind of just generally talk about, let's compare the two distributions. So because you have to do that, and I think, is it problem 5? I don't know which problem it is. 6, 5, I'm not sure. 5, okay. Because I'm asking you to do that for a grade, these are the things I will be looking for, okay? Let's compare them. The first thing you want to do is to compare shape, because you are literally going to, you can say shape and then write a couple sentences. Center, write a couple sentences. That's fine with me. Let's talk about their shapes. Let's compare them. What would we say? I don't know, let's call this the red versus the green graph. I'm making it up. Or let's do Algebra 2 versus AP Stats. Yeah. Because we think we're smarter, right? Alvarez? Last name Alvarez? Okay, that's you. Okay. Is this guidance?
Yes.
Okay. Mr. Lindenberg? Yeah, he never doesn't ever do anything. Okay, he doesn't have a check. There you go, sweetie. No, go ahead. You should be ahead. I hope it doesn't take you that long. All right. So let's compare. Let's talk about shape. What would you say? What would you say about the shape of Algebra 2? Centered's not a word I use for shape. Symmetric is a word I use for shape. Cluster, you cannot tell a cluster from a box plot, ever. Cluster you can tell from a histogram, though, or a dot plot, but you can't really tell from a box plot. But I would definitely say relatively symmetric. Okay? Now, why am I using the word relatively? It's not exactly. It's not perfect. Okay? It does, to me, look like this box is a little bit smaller than that one. Wouldn't you agree? There's probably a little bit more some more values here than there are there, but relatively symmetric. So that's a word I would use. Okay? So Algebra 2 is relatively symmetric. Okay? What about AP Stats? Slightly skewed right. Okay? I would say, even to go far as saying something like, there are fewer people, and this is hard to wrap your brain around, because the whisker's longer, but because the whisker's longer, there are fewer people in this range. So more people scored above an 87, well, I shouldn't say that way. More people scored in the upper 25% in Algebra 2 than AP Stats. Does that make sense when I say it that way? Longer whisker means fewer people. Shorter means more people. There's more data values there. That's important, okay? Because you're going to be matching up histograms to box plots in a few minutes. Okay? All right. So what are we going to say about AP Stats? I'm sorry. You said it was slightly skewed.
Right.
Right, because there's fewer data values over here. Now, here is a problem. We've addressed shape with both of them. Shape really determines the next measure I pick. Shape, center, spread. So let's deal with center for a minute. When we deal with center, well, it depends on what the shape is, but they're different shapes. So which one should we pick for the measure of center? Your choices are mean or median. I heard mean. Do you guys agree? Well, you said median. I'm sorry. Do you guys agree with median? Well, you have to use, if you're going to compare, you have to use the same measure of center for both. Okay, that's important. I agree. Median is better. Only because we have one of them that has a slight skew, so therefore to compare we should use median. If I ever ask you to justify why you chose something, that's why. Okay? Because of the shape. I'm going to say that again because that's going to be a quiz question. Hint, hint, wink, wink. Justify why you chose the measure of center. Okay, good. So we're going to use the median. So when you are comparing, you need to say that one has a higher or lower median than the other. So look up there. Which one, what sentence would you say? Say it again. Algebra 2 has a higher median than AP Stats. I agree. Algebra 2 has a higher median than AP Stats. So that's what you should write. Let's write it. Let's see you write it. You should write it. Good idea. Okay. The reason I'm telling you this is because number 5 on your thing you're going to turn in today, you have to compare their whatever measures of center you chose. Did you choose median? Did you choose mean? I don't know. Okay, so we're going to say Algebra 2 has a higher median which we'll even give a number. It's probably a good idea to put a number to it. So that's median was 79. Then AP Stats. And we'll approximate it with the graph. What would you approximate it to be? 76, 77, something like that? I don't care. I don't know. As long as you're 1 or 2 off, I don't care. We have addressed shape and center, and we have compared them. The last measure is spread. Okay? The 5-number summary is a general version of spread. Really, a better picture would be an IQR. What does IQR stand for? Interquartile range. So let's talk about that, and then we'll come back and finish this part. Okay? So what is IQR? Okay? Hang on. We had the box and whisker plot. What's the IQR? Interquartile range. The definition is simply Q3 minus Q1. We actually used this last class to do an outlier test, didn't we? So you need to know that. You had to do an outlier test, I believe, on problems 1 through 8, didn't you? Okay? You will have to do an outlier test on your quiz that you're having that's coming up. Okay? So you need to know how to do that. Q3 minus Q1 in this case is just 17. The IQR is one number. This is the work that is involved in finding the IQR, but the IQR is actually simply just 17. I would prefer you to show me how you found it, to show me that step, but the IQR is a single number. Okay? So, and we talked about outliers already. We've done the outlier test. Remember that from last class? Well, quarter 3 plus, because you're going to look at adding quarter 3, and then you're subtracting from quarter 1. But it's 1.5 times the IQR. You want me to write it down again? That gives you the upper fence, and this gives you the lower fence. Okay. But we talked about that last time. So if the interquartile range is 17, for Algebra 2, what would the interquartile range of AP Stats be? Oh, I went too far. Here we go. Really? There we go. Okay, honestly, before I even find IQRs or find numbers, I should be able to, that visual picture, that box plot for both of them, I can tell you right away, Lena, which one has a smaller spread than the other. Can you tell me? Between Algebra 2, the red one, and the green one, which one has a smaller spread? Sure you do. One of the boxes is bigger than the other one. Algebra 2 is a bigger or a smaller one? Look at the box. The box, not the whiskers, but the box. Which one's a bigger one? Algebra 2 has a bigger spread. Then that's a visual cue. We can make that statement simply based on the graphs. Algebra 2 has a higher spread. Question, Larry. Y'all got to stop with the PP. No, not till I'm done. Unless there's an emergency. Let me just finish, then we break the, yes. Okay? Okay, I don't leave in the middle of class. What if I had to go? Shape, center, here comes spread. Algebra 2 has a larger spread. We're comparing than AP Stats. We should put, the numbers are not enough. Okay, you have to say one's larger or smaller than the other. But you need to do also put the numbers. So the IQR of Algebra 2 was, we said, what was it, 17? Okay. What is approximately the IQR of AP Stats over here? Okay, let's just approximate it. I keep drawing all over my thing. So we'll approximate it. What did we say this one was? 77? We'll say this is 73. So what do you think? Oh, that's not 77. I'm sorry. That would be 83. So what would you say, 10? It's approximately 10. Larger spread. What does that mean? If the spread's larger, what does that mean? Hunter? It's more widely variable. Here is a word you're going to hear and use a lot in this class. Variability. Okay? Which one of those sets of scores is more variable than the other? And I don't mean variable like X, Y, Z variable. I mean like they're different from one another. Okay? So they're not going to change because they're set values, but statistic variability is a definition I'm going to have you look up and define, okay? Because I think we all need to know what it means. But Hunter's right. I think that the AP Stat scores are more clustered together. The spread is smaller. There might be a few out here and out here. Could you match the picture of that to what a shape of a histogram might look like? Let's try that. Oh. And it looks to me like, I think the bottom two, everybody just about got, 4-1. It's the top where the 3 and the 2 got switched around a little bit, okay? So I think it's a good discussion to have. Let's make sure we agree that this really is box plot 4 and box plot 1. To me, I think it's a little clear because these are obviously the skewed ones. Wouldn't you agree? Skew is a little bit easier to match up. For histogram C, does have a skew right, and therefore so does box plot 4. Therefore, those do match. Our histogram D has a little bit of a skew left. Not as sharp, but it does have a skew left. So that's why skew left matches with box plot 1. So I agree. I think those are correct. Now, when we look at 2 and 3, as far as box plots go, really the only difference between the box plots is what? Not the what about the whisker? Which whisker? Right. Where the first quartile is really the difference. Wouldn't you agree? Okay? So that's where we have to think about. When we think about 25% of the data being in that left whisker, right? So 25% of the, I put 4, sorry. I meant up here. 25% is between 0 and 20 here. 25% is between 0 and probably 25. Which means if we're going to look at box plot 2, 25% is going to be between 0 and 20. Which means that more data is going to be to the left here in box plot 2 than there will be in box plot 3. Does that make sense if I say it that way? Hopefully. Okay. So I'm going to be looking up here at the histograms at the first 2 here is really what we're looking at. And if I look at this particular graph and we think of 20, okay, which one looks like it has more of the data, or 25% of the data there? Okay, so that's really what we're looking at here. So knowing that, look at what answer choices you picked. What do you think the order goes? Does it go 2, 3, or does it go 3, 2? It goes 2, 3. The upper quartiles are the same for the both of them. They're both at like 70. Okay, that's another way to look at it. I really like what Kyle said. Maybe rather than focusing on the quartile 1, let's look at the spread. The box is bigger in box plot 2. It's more spread out. Would you agree with that? Therefore, if you look at the histogram, the data is more spread out in box plot 2. That's a much easier way to look at it. Okay? Graph histogram B is more clustered together. It's more unimodal, has a smaller spread, less variable, all meaning the same thing. Nice. Good? Make better sense when I say it that way, or when she said it that way? Good. All right, go ahead and put that away for me. On your quiz that you have coming up, okay? The quiz will be next Monday, the first quiz of the quarter. You will have to do some of this matching, whether it be matching the shape to the graph or the situation to the graph like we did last class. That's a possibility. Or whether or not you have to match the box plot to the histogram like we just did. That's a possibility. But you will have some kind of matching situation going on the quiz for Monday. Okay? All right. Let's go back just for a quick second because I really do want to give you some time to finish up part 1. Okay, I promise you I will give you some time, and I also need to give textbooks out today. So let's just make sure we've finished everything. We talked about the quartiles. We talked about box and whisker plots. We've talked about outlier tests. We did that last class, correct? You need to show work to be able to do that. Just a definition. A modified box plot is simply, just when you hear me say those words, just means it's a box plot that shows the outliers. You will always, if they have them, show them. Always. Okay, so just, you might hear me call it that. That's all. Sammy?
So before, like, the AP exam,
Shh.
is it kind of like when I test, like, when there's, like, a vocab where you have to, like, define it?
Mm-mm. You never have to define it.
So we don't need to know, like, that's it.
You need to know what they are, but they're not going to make you define them.
So, like, okay.
You know what I mean? Yes, Timerson.
Do you want us to do an outlier test every time we make a box plot?
That's a really good question. I hate to say the word every time because there could be a situation where every doesn't apply. But usually I want you to check for outliers, especially if it's anything in question. Like maybe it could be. So on the quiz, I will say, and I will be specific, test for outliers. Okay? And I will do that on the first test that we have on univariate data as well. I will tell you when an outlier test is appropriate. But that's a really good question. Okay. Let's just make sure we've finished up everything. Okay, I'm going to stop here, okay, because I don't believe, are there any questions on standard deviation on questions 1 through 8? I don't believe so, right? So I'm going to stop there. And then when we get to although you have standard deviation in your homework, don't you? Isn't part 2 ask you to calculate the standard deviation? Okay. Can I just tell you quickly how to do, guys, please listen. We're going to do it by hand next class because it will be on your quiz, how to do it by hand. But for homework purposes, I'm going to show you what number on the calculator the standard deviation is. Because really all I care about for part 2 is that you can compare them and figure out how it changes. Okay? So if you look at your calculator, and we have to talk about what the variance is and all that. You should already know that, but that's okay. If you go to StatCalc 1var Stats, this number, well, the SX, now if you're an IB math, different. Okay, if you're an HL or SL, they use the little sigma to represent standard deviation. It has to do with whether you divide by n or n minus 1. Above our pay grade, we don't care. Algebra 2 uses the sigma as well. Okay, us AP Stat people always use S because SX stands for sample standard deviation. And we treat everything as a sample because we don't think that populations can be attained. Okay? So we will always in this class use S. If you're in Algebra 2 or any IB math, you use the sigma, which is the little circle with the one right before the N. Okay? Yes?
We use for HL math, for sample sets, but then for probability stuff, we
Right. I know. Right. There's a differentiate. You differentiate between the two, which is great. But we always use S. Okay. So I just want to make sure we tell you that. So when you calculate it at home, when you're asked to on part 2 to find the sample standard deviation, or I'm sorry, I won't even say to find the standard deviation, use the S. Good enough? It is a measure of spread that we will discuss next class. It talks about how highly variable the data is away from the mean. Okay. So it's another measure of spread. All right, I'm going to pause or stop the recording.